So today, as an introduction to networking, we are going to finish this number 1, 2, and 4. We're going to understand these 4 things and we are going to finish this. IP addressing is the place where we have to spend a lot. So uh, though you may say you know subnetting, still there will be a lot to learn in this class. Even if you have learned somewhere else, still you will have something more to learn here. So we will spend some long period of time in this third one. But first, second, fourth can be finished in a day. Let's try to learn what they are trying to help us understand. First is the network basic. Basics of networking. And what is networking? When you say basics of networking or fundamentals of networking, there is a medium through which we are able to communicate and share resources. We call that as network. The interconnection between the users and the servers. When I say servers, don't think only, I'm talking about a server machine. Anyone who serves is a server. I'm a server here. I teach a kind of server. You are users. In networking, when you request something, then you are a user. Whoever responds to your request is a server. In another word, you can say client server. Everything is client server relationship here in networking. One is the requester, another one is a responder. For this to happen, there is a huge setup. Many wires are involved, many radio waves are involved, many equipments are involved. All together is what we call as networking. We have different operating systems used by end user. I'm using Microsoft operating system. Some may be using Ubuntu. Some may be using Linux. There may be some other flavors of Linux, SUSE, Red Hat. There may be many versions of Windows that you all use. In spite of all these variations, we are able to communicate. It is because of this OSI. This Open System Interconnect OSI is a standard using which all the equipments in the network are built. Every device have come up with this idea called OSI, Open System Interconnect. Open System Interconnect. It's a standard. When we follow that standard, then we can be part of network. Like when I speak in English as a standard language, irrespective of continent, people follow my teachings, not just from Middle East or only from South Asia. Students are all around the globe. It is because I have followed one common standard language. How I got all those students? Because they understand what I speak. If I would have spoken in my own local mother tongue, that would have not been possible. Likewise, every single network components devices, hosts were developed by referring to this one common standard book called Open System Interconnect. See, this Open System Interconnect standard has been proposed by ISO. That's the standardization organization, right? ISO certified, many things you have seen. ISO certified hotels, ISO certified vehicles, which means what? The standard is followed in the hotel. It's a ISO certified 5-star hotel, which means you don't need to ask someone whether there will be a bathtub in the restroom. Definitely there will be a bathtub because it is ISO certified standard. If it is a 5-star hotel, if it is ISO certified 5-star hotel, then no need to question whether there is a bathtub with a hot water. You don't need to ask someone whether there will be a heater in the room because according to the ISO standard, it should be there. Likewise, whatever is necessary to communicate that is prescribed in this book called OSI. And when a vendor follows it strictly and build their device can be a part of network. Your laptop is one of the device with which ISO is implemented. Same way my laptop. Not only just laptop, there is a lot of intermediate device between your laptop and my laptop. Currently, we both are communicating. It is not just because of our two laptops. There's a very big backbone cloud in between you and me. When we say cloud, to make it simple, we say cloud. Cloud, what cloud? Is it a water cloud? No. Here it means there's a big infrastructure which cannot be easily explained or pictured in one line. So they simply say cloud, cloud, cloud. It's nothing but big pool of resource in between your laptop and my laptop. If that cloud don't exist, if that pool of resource don't exist, we can't communicate. Now all those devices, the pool of resource, have followed this OSI, Open System Interconnect. So your laptop, my laptop, and the middle device all follow one common standard. That's why we are able to communicate. And this OSI has got 7-step approach for successful communication. 1, application layer, right? Application layer. Because you have already gone through this video, I'm asking if you know, you answer. And number 2 is layer 6, which is presentation layer. Layer 5, which is session layer. Layer 4, transport layer. Layer 3, network layer. Layer 2, data link layer. Layer 1, physical layer. So this is describing what need to be done for successful communication. If you fail to provide IP address, then your packet will not go anywhere. Important, right? So someone should take care of it. Network layer takes care of providing IP address. Data link layer is taking responsibility for providing MAC address. Transport layer takes the responsibility of providing port numbers. Port numbers. See, port numbers are like this. If you go to some office, I have not seen in every office, some office where people who work around the clock, multiple shifts are there, maybe 2, 3 shifts people come, different people come in different timing. For them, there is a vending machine. In the vending machine, they keep food. They keep ready-made foods. Sometimes, ready-made the drinks, soft drinks. And there is a number there. Now, when you scan the QR code and press the number here on the refrigerator or whatever the machine, the amount when you put in the QR and pay the amount, you get the food out. So, for example, if I need a coconut water, so there is a glass of coconut water inside the machine. I can see with the number 18. When I press 18, I get coconut water. I don't get Coca-Cola. I get coconut water because number 18 is given to coconut water. Likewise, in the network, we have various services. To ask the service that we need, to request the service that we need to, from the network, you need a service. What? Telnet service, SSH service, or HTTP web page service. So there is a number given to each service. That is what we call as port number. If I am telnetting, the word telnet, Telnet, it's a human language. How network will understand it. So there is a port number given for telnet called 23. When you say 23 as a port number in the packet and send it to the remote device will understand that you are requesting for a telnet. That's what port number. So the transport layer is also adding something very important message to tell the receiver what you are looking for. Simply having address is of no use. IP address, I know the IP address of the device. So what? What I'm going to get with the IP address? Nothing. After going there, you should open the mouth and say, I need a chocolate. Only then the shopkeeper will give you the chocolate. If you simply know the address of the shop, it's of no use. So what you are looking for is mentioned using port numbers. This number is reserved, like 23 is reserved for Telnet. 22 is reserved for SSH. Likewise, you have 1 to 1024 port numbers already reserved for various services. So using that number, our devices will send the request. See, again, I want to tell you, you no need to worry about what number to put. This 4 layer is controlled by operating system. So we are not going to put 23 and send a packet. When you telnet, operating system will do it. So, but it is good to learn few numbers by heart. As we are going to go through various topics, you will come to know various port numbers. As of now, just learn only 2 port numbers, at least 23 for telnet, 22 for SSH. Okay. SSH, secured shell, 22. And it is TCP 22, not UDP. TCP. What is the difference between TCP and UDP? You have seen in that video, but I want to quickly explain you one more time. Transmission Control Protocol, User Datagram Protocol. These two are important, but one of this is used by each protocol. For example, if I am telnetting, UDP will never come into picture. It is only TCP. But if I am using some messenger, we do know WhatsApp. That WhatsApp messenger, it won't use TCP. So depending on the application that you pick, if it's a WhatsApp application, app, we say no app application, WhatsApp. If it is WhatsApp application, transport layer will decide to use UDP. If it is a telnet application, then transport layer will decide to use TCP. So again, you are not going to control those things. Which one to use? You don't need to control. You don't need to say. All are taken care by the operating system. Session layer fixes the time frame. Presentation layer encodes the human understandable thing into machine understandable. That is why it is called presentation layer. You see, people come from different language background. Their brain will think in their mother tongue. If a guy is from Andhra Pradesh, when he comes into the IT as a fresher, his brain will always think in his mother tongue, Telugu. And when he speaks to us, he will speak in English, presenting it in English. If he speaks in Telugu, I won't understand. So what he does is, when he speaks to me, he presents in the language which is acceptable, understandable. Same way. The applications use a language which users can understand, human being can understand. That's how the applications are built. But it is the presentation layer which interprets, encapsulates into a mission understandable language. That is why it is called presentation layer. If we don't present, then the machines won't understand the message that we are trying to communicate. So the presentation layer is also important. Application layer, the applications that which we use to interact with the network. So this Microsoft Word which I'm using, is it a network application layer? No. This cannot interact with the network. But the Google Meet that we use, that's the application which is responsible for this class, this online class. That's the application layer where you checked into the class. It is through that application my screen is visible for you. My voice is carried into your laptop. That's the application layer. So any application that interacts with the network is an application layer. Presentation layer, session layer, transport layer. Transport layer also does one more thing: segmenting and sequencing. According to the capacity of the physical layer, you see, some roads are 80 feet road, some roads are 10 feet road. In some old cities, if you go, you will see even just 8 feet road. All the houses are fully packed, congested. 8 feet road, 15 feet road, 10 feet road, 80 feet road, 30 feet road. You will see cities with different road size. I've been to some olden Turkish villages like Istanbul. Though they are very famous, but they are very old. The streets are just 10 feet. Only 10 feet. In the 10 feet, both the side you will see people sitting and drinking coffee, tea. Car will also go in the 10 feet. Only 10 feet road. People also will be sitting. Car will also go. Mostly the streets are one way. That is what called as duplex in networking. One way, half duplex. Two-way means full duplex. If you are able to communicate only one direction at a time, only one direction at a time, either it can go or receive. Such ports, devices, they're called half duplex device. Full duplex means parallelly they can receive and send. That is full duplex. Now, according to the physical layer, as I said, some are 10 meg bandwidth, some links are 100 meg bandwidth, some links are 1000 meg bandwidth. So when the capacity is big, the transport layer will segment packet big, will cut the data in a big size because it can be carried by the physical layer. If the physical layer is narrow, then transport layer cannot break your data into big pieces. According to the capacity, it will break. If it don't break, then it cannot be sent. Very important. Our data will get broken into pieces. Now, what size it has to be broken is determined by the transport layer according to the physical layer's capacity. We call that as segmenting. So our data in this place, here our data we create When it comes to this layer, it is called a segment. One big data is being cut into multiple pieces according to the capacity of the physical layer. Now each segment is numbered so that it will be easy to rearrange on the receiving side. We call it as sequencing. That's transport layer. Network layer will provide the IP address, sender IP address, the destination receiver's IP address. Data link layer will provide the MAC address and both sender and receiver from to source destination MAC address. Source destination IP address is given by network layer. Source destination port number is given by transport layer. At last, it is now converted into electrical signal or radio waves by the physical layer. It goes in the form of zeros and ones. We call it as binary electrical signal. If you are having a wireless laptop, then it will go in a radio waves in same bits and bytes, zeros and ones. If you have a cable, then it is electrical signal. Now, these 7 layers mandate. Even if one layer don't add its property to the data, then the packet will not know. The devices which receives the packet or the device that trying to send the packet will not know where to send. Adding the 7 information to a data so that it can be a eligible, acceptable data in the network, we call this as encapsulation, adding the 7 layer properties. Receiving side, the receiver will check whether the MAC address, the destination MAC address of this packet belong to them. If so, they receive it and they process it. There they do decapsulation. Sending side encapsulation, receiving side decapsulation. So this is OSI layer. Now the same OSI layer can also be simplified as TCP IP. Both are same actually. Both are one. It's a model. But the operating system guys, they don't make it a 7-step. They make this 3 as 1 step. Let me show you that. Now, if you see here, simplified layers. These 3 layers becomes access layer, network access layer. Sorry. This guys have put ulta. This physical layer is what? Network access layer. And then these 2 layer is called as internet layer. This layer 3, layer 2. Internet layer. And this is same. Transport layer name is same. But here it comes as layer 3. In TCP IP model, this is layer 3. But in here it is layer 4. According to TCP IP model, this is layer 2. Both layer 2 and 3 of OSI is layer 2. Layer 4 here is layer 3. And these top 3 layer, as I said, it becomes one single layer called application layer, layer 4. This is what they call it as TCP IP model. TCP IP model. Both are same. This is a simplified version. You are accessing the network via physical layer. So they have given network access layer. Now the devices are identified using IP address and MAC address. So they put it as a simple single layer called internet layer. Transport layer is transport layer. And these three are taken care by the operating system, which is also an application. So they name it as application layer. I told you, these three things, not only these three, even fourth, all taken care by operating system. But here we have transport layer separate because it is also doing segmenting and port numbering. So this is a simplified version of OSI, TCP IP model. Let me bring another picture. Now, you see here, the first three upper layers are application layer. Transport layer. Segment is happening. And this is the place where IP address is given. We call it as packet. Here, also packet, but this is the combination of data link layer, the MAC address, including MAC address. And then the physical layer, this is the place where the traffic goes in bits. All right. So a simplified version of OSI is what TCP IP. Do you have any question on this? Port number shortage won't come because we don't have that many services. We don't have more than that. That itself is too much. 1024 port number itself is too much to identify service. So if you take any communication, you will have a port number already there. So there are again a lot of unreserved port numbers. As I told you on the other day, we have 16 bits for port number. 16 bits. So 2 to the power of 16 will give you 6553502. You have these many port numbers. Reserved port numbers for well-known services are 1 to 1023. 1024 onwards to 65535. They're unreserved. From there, you can request and reserve if you wish to. If you have your own application, again that will be like vendor specific port numbers. But universally there is only 1 to 1023 known port numbers, and that is more than enough. Right, to identify services, we don't need more than that. Any other questions? Any other question? Okay, if no, now let's quickly have the picture again. Here it is said these two are put together as one. Fine, that is also okay. And network layer is internet then. Here, this layer 1 and layer 2 becomes one layer here. Instead of calling network layer, we have internet layer. Transport layer is same transport layer. And these three are one. Okay? So it's not these two internet. Network is internet. Initially, I said wrong. Network is internet. Only these two are this one. The nice name was given in the previous picture for this layer. That's the access layer. Network access. This is a nice name. Network access layer. Network access layer. So network access layer is physical and the data link layer. OSI's layer 1 and layer 2. This is layer 3 of OSI. And this is layer 4 of OSI, and this is 5 to 7. Right. Now, if you see, there is a LAN network. What is a LAN network? The local area network is the one which is, hold on. Okay. Local area network is the one which has got all the devices in same network. Same network. Say, for example, when you live in a village, everyone in this village will have same pin code because it's just a small village. Same pin code. Only one pin code, which means what? They're within one judiciary, one one group, one village. But if you take a city, every small part of city will have different pin code number. Take, for example, Chennai. You will have Chennai 1, Chennai 13, Chennai 20. The pin code varies, but they belong to one city. That is what we call it as metropolitan area network. Multiple networks within a metropolitan city. And wide area network is Chennai and Bangalore. All throughout India, all throughout the world. So you see, if you have a network, single network for all device, like if you take this computer, which is interacting, this is the sender, and here is the receiver. If the sender and receiver are in same network, this is 10.0.0.1, this is 10.0.0.50. There may be another computer here, 10.0.0.30. They're all in single network called 10.0.0, which means LAN, local area network. To connect these three, what is needed is a switch. Switch is a LAN device. Switch uses MAC address to communicate. Switch is a layer 2 device. Why? Because in OSI layer, Layer 2 is the one which is assigning MAC address. Layer 2 the one which uses MAC address. Network layer is not using MAC address. What do they use? Network layer uses what address? Network layer IP address. So we call switches LAN device because they do use only MAC address for communication. More about it we'll talk when we talk about switches in the next topic. So introduce you here that switches are called as layer 2 device because they deal with MAC address. OSI layer 2 is data link layer. Data link layer is the one which is responsible for those MAC addresses, source destination MAC addresses. This is a LAN. What I have drawn here is a LAN, local area network. Now, if I will have like this, 20, 30, then this cannot be a switch. What is needed is a router. We draw like this router. Whenever you bring router into picture, it means wide area network, WAN, because you got multiple networks. See, this may be in same building, or this may be a very big internet. This is in Melbourne. This may be in South Africa. This may be in Congo. No, sorry. This may be in Colombia. No. This may be in Houston. They are WAN. Even if it is in a single building or in different location, geographical location, still they are WAN because router is involved. Router is involved whenever you are communicating between different network. Without router, communicating between different network is not possible. Router is layer 3 device because it is dealing with networks. 10 network, 20 network, 30. Router is network layer device, layer 3 device. So that's about router. So we got switch, layer 2 device, router, layer 3 device. Because router deals with network, router connects between network. We call it as layer 3. Switches help to communicate between the devices that are in same network. So you call it as LAN. See, MAN is another term only within a metropolitan city. Again, it is again another WAN only, wide area network, because different networks are there, but it is within the city. No need to think too much about MAN. This is just one term to say that network is not too far. All the networks are within one city. That is not important to spend time. What you have to know very well is these three things: LAN, WAN, and WLAN. WLAN is nothing but a wireless switch is there. Instead of physical switch, we call it as WLAN. So you got same network. You got same network. Sorry, again I wrote 20. Sorry. Same network, but these are all radio waves. And these three communicates through. This is a switch, but it's a wireless switch. So because of this switch, this can interact, and so on. Without a switch, three devices cannot communicate. Without a switch, even though all three have got the radio, it can only talk to this or this, this or this. But when you keep a wireless switch, via the wireless switch, all three can interact at the same time. Right, that's about the introduction to networking. Now, networking devices, you have already seen in the video. We have hub. Hub is a multi-port repeater. We got many ports so that you can connect more device. Access point, this is what? Access point, wireless switch, which is access point for all to communicate at the same time. Switch is a layer 2 device, uses MAC address for communication in the same network, LAN device. Router is a layer 3 device, WAN device, which uses IP address and networks to communicate. When we say end device, the end device may be a client or a server. If a device is requesting, then it is a client. If a device is providing response to the request, then it is a server. Those are all end devices. End devices. Communication is happening between these two devices. End device. Servers. For example, we all have Gmail, which is an end device application. But when you go Gmail, there is one common server there somewhere in the internet serving all of us. That's a server. When you give your credentials, you will be taken to the hard disk where your mails are kept in Google. They are servers. They have a big pool of hard disk storage. When I log in to my Gmail, there is a hard disk there kept reserved by Google for me. From that location, I'm able to read my mails. So Google is a server. YouTube is a server. They keep all your videos there so that any end device can request and see those videos. Right. So that's the end of network device topic. Now coming to this last topic, we'll talk about the third topic later, IP address, MAC address, subnetting. Now coming to this last topic. In layer 3, we have IP address. Protocol IP works. But in layer 2, a protocol called Ethernet works. And this topic is about layer 2, Ethernet, and layer 1, cabling. Ethernet is one standard, one protocol, layer 2 protocol. And that protocol works on a special type of wire. We call this Ethernet wire. See, for our fans and tube lights, if you see a wire, there will be only two wires. One is plus, another one is minus. That is more than enough for electric signal to make your fan and light work. But for data to be carried, there's a special set of wires needed. Only then this Ethernet protocol can work on it. We call that as cross straight through rollover cables. According to the purity of the copper, the speed will vary. If it is more pure, more bandwidth you will have. Yeah. So these are all actually for general knowledge topic. You are not going to work on all this, but you should know what they mean. That's why we are here. This Ethernet standards, some cable bandwidth is only 10 meg, some 100 meg, some 1000 meg, which is also called as gig Ethernet. 1000 meg is what? Gig Ethernet. Actually, we have now 40 gig also, means 40,000. Very rarely you will see 40 gig, 100 gig. 100 gig is also there. One cable which can accommodate 100 gig. That's actually, along with Ethernet, there is another fiber optics technology works together to provide you that much. Let's not get into that. But what I am trying to say here is we have different speed in the Ethernet. And they are copper wires. According to the copper purity, the amount of bandwidth will vary. So if you go to a market and buy Ethernet wire, they will ask you what Ethernet. Is it Cat5 or Cat6? Category 5, 6. Which means they're talking about the speed, Cat6, like 1000 meg or 1 gig. All right, so cables, same cable, but can be designed as a straight through cable, or it can be designed as a cross cable or rollover cable. These three differences are important for those people who will work in layer 1, like connecting, plugging, unplugging the cables. They will do this type of cable wire arrangements. Let me show you that. Now let's see one by one. What is that straight cable means? You see, this is a straight cable. Why do we call it a straight cable? The arrangements, I told you, you have more than two wires. For a tube light, for a fan, you need only two wires, plus and minus. But for the data to be carried, you need more wires. How many? 8 wires. Only then the Ethernet standard can work. This we called as white orange because you got white and orange. So small o. This is orange, green, blue, white, blue, green, brown. Sorry, white, brown, brown. You see? But when you go to the other one, you don't see the same replica. Look at this. I repeat again. This arrangement is the same. It's a replica here. We call it as straight cable. You see, this is the jack. Inside this jack, if you put this wire in this arrangement on both the end of the wire, wire will have two jacks, right? One end, each end will have one jack. So on both the end, the registered jack 45, this is what we call as RJ45, registered jack 45. Inside this, when you arrange the wire like this, we call that as crimping work. Crimping. Layer 1 people will do that. L1 guys in your data center. If they arrange both the end of the wire like this, then it is straight cable. If they do something like this, you see, here this is matching, but these two are not matching. The first one has become the third one, and the second one has become sixth one. If so, you call it as cross cable. Cross cable or crossover cable. First one becomes the third one, second one becomes the sixth one. All other things are just moving. You see, this one is more here, and then this one, because the first one has gone to the third one will come to the first position. Third one, second one goes to the sixth one, which means sixth one comes to the second position. All other things will be in the same place. So when we talk about cross cable, you need to only remember this. First one will become the third one, which means the third will be shifted to first. Second one will go to the sixth one, which means sixth one will become the second one. Now, if you arrange cables in this manner, you call it as cross cable. In straight cable, just same design, same replica, no change. First is first year, second is second year, no change. But when you do first color wire as third one and second color wire as sixth one, then you call it as cross cable. Now, rollover cable is this. First one goes to the last one, second one goes to the second last one, just the inverse. Here the first becomes the last and last becomes the first. This is rollover. Now where to use this cable? Where should I use rollover cable? If I'm using a console cable, meaning that cable is not for communication, that cable is to interact with the router or a switch. Those cables are rollover cables. They're not forwarding any data from one end to another end. This is just to manage the device. The management cable, blue color cable, console cable, they're called as a rollover cable. Now, where to use cross cable? Cross cable is used whenever you are connecting between two similar devices. Similar device, you cannot use straight. You must use cross cable. For example, you have two computers. What cable you will use? Crossover cable. And if you have dissimilar device, for example, you're connecting a computer with a switch, then you will have straight cable. I repeat, dissimilar device, straight cable. Similar device, cross cable. Management console port needs rollover. Is this clear?